what happened, what is wrong. So let's talk about generation of computers. So how this computer thing started and what is the idea behind everything, how computer works and things like this. So the most important part in the puzzle is transistor. So how this transistor is important? This transistor act as a switch. Okay, and now switch means why do you need switch? So when you have switch, you switch on and off the current through it. So that's why you need switch. So same is the work of transistor in the computer. It switches on and off the electricity inside the computer. That's it, the basic simple idea. So when it switches on the circuit inside the computer, the digit 1 is represented by that. Means by the flow of current, you represent the digit 1. And when the switch closes the current, then there is no current in the wire, then you represent that state by 0. So now you have only two states. So if your current is flowing, you will represent that state by 1. And when your current is not flowing, you will represent that state by 0. So these two states are called binary states, or you can also call them, uh, depending on voltage, sometimes they are also called digital, binary. So see, by these two states, by these two binary states or by these two digital states, you are trying to represent or process or save all the analog information of this world. So when you are trying to uh, save or trying to represent all the analog information of this world, so then you have to be logical, because in your analog world there are so many different possibilities or combinations available practically of anything. Let's say you'll say color, you'll say choices. Very less things are represented in two states. There are things in two states, but very less, not always you have things in two states. So when you have things in two states, then you have things like yes, no, male, female, good, bad, black, white, something like that. That time representation in terms of 0 and 1 is easy. So for, let's say for yes, you will on the current, so your transistor will be on, and for 0 you will off the current, so your transistor will be off. But when you have so many other states, more than two, then there is a challenge. How will you represent? Now see, for that you have to make combinations of 0 and 1. And now the concept of bits comes into existence. So when you make combinations of 0 and 1 to represent analog information of the world, then the concept of bits comes into existence. So when you were representing only one state, then you had only 1 0 and only 1 1. So either you had 0 or 1. But now you have more than two possible states. So now you have pairs. So either you will have 0 0, or either you will have 1 1, either you will have 0 1 or 1 0. Right? You can have pairs of 3 if you have number of possible combinations. If they are more, then you have 3 pairs. You can have 4 pairs and so on. So now to represent more and more information, these number of bits will increase. So when you have much bigger um, bigger combinations of objects or bigger combinations of things, then these number of bits will increase. So now see, now this whole system is in the base of 2. Now 2's power become very very important. Why they are important? They are important because now when you have 4 different combinations, so 2's power 2 is equal to 4. So when you have 2's combinations, 2's power 2 is 4, then you can represent 4 different things. But this thing is number of bits. But to represent 4 different things, you will need 2 bits. Similarly, to represent 3 different things, you need 2 raised to the power 3. To represent 8 different things, you need 3 bits. Similarly, to represent 16 different things, you need 4 bits, and so on. So these bits will keep on increasing, and when you reach 2 raised to the power 10, that means 1k. So you can 2 raised to the power 10, you can say 1k memory or 1k camera pixel, whatever. So now hopefully you got the idea what I want to say. So that's why transistor become very important. So from transistor we make gates and or not. From transistors we save these numbers. So a device where number of transistor will be more, so that device will be much better in terms of efficiency or in terms of accuracy or less time consumption, etc., etc. So you need more transistors to make more sophisticated device. Now when you make memory or processor, whatever you make, mostly gates are connected there, and in gates basic gates are very important, and or not. So till here you are clear. So I am just giving all this in brief. Then the most important thing is IC. So what is IC? Integrated circuit. So why integrated circuits are important? Now you have packed these transistor as a circuit inside a silicon chip, single silicon chip. And how you made that possible is, a single silicon transistor is made by a single silicon. So now in that single silicon you can make 2 transistors, because how you made that transistor? You just doped means you just added impurities to the intrinsic semiconductor element. So you took silicon. And so what is silicon basically in the nature? So purest crystal of sand is silicon. So you took that and you added impurities into it, you made your transistor. So now you have one transistor, but if you make that transistor small, in the same crystal you can have 2 transistors. And in the same crystal, if you make the transistor small, you can have 3, 4, 5, 6, 10 transistors in one crystal. That is called chip or IC. So let's say if you have 10 transistors in one single IC and you somehow interconnected them and you made a circuit of AND gate from that, or adder from that, or subtractor from that, or a memory element from that, so that will be called IC. So IC means integrated circuit. So you integrate the whole circuit through transistor inside a single silicon chip. So an IC can be an adder, IC can be a processor, IC can be a memory, anything. So this is now the basic concept, IC. Now you made memory and CPU from those IC. And when you packed everything inside one IC, memory, CPU, everything, that IC is called microcontroller. So now you have 2 different type of processing devices. You have microcontrollers and you have microprocessors. Now you can have different kind of combination, so that will make the architecture of that device and from there this computation have begun. So now we'll stop here because otherwise this lecture will become too large. So we'll continue this. We'll see what is the response we are getting on this introduction part. Topic you want uh, the discussion to be on, and then we will make a video on that. And for next time, we will continue this journey of processing from here onward. So thank you very much. Please like, share and subscribe.